Okay, good morning. Welcome to
And they have number 752.
FamilyMath752. So these are two problems. Where are they from? The 2005
Yeah.
MC10A that gave you a little trouble today. I thought I'd talk about these problems with both of you. It's a pretty cool problems actually. So problem 18 says Team A and B play a series. The first team to win 3 games wins the series. Each team is equally likely to win each game. There are no ties, and the outcomes of the individual games are independent. If Team B wins the second game and Team A wins the series, what is the probability that Team B wins the first game?
Alright.
Okay, Team B wins the second game and Team A wins the series. What is the probability that Team B wins the first game?
Alright.
Okay.
Well, so we can list out the possible ways the series can go.
Okay.
I'm just gonna mark, like, if with a B if Team B won the game, and if Team A won the game.
Okay, that's fine.
So there's only one way for B to go first,
Uh-huh.
and that's this series.
Right.
Then there's A, B, A,
Okay.
A, B, B, A, and A, B, A, B, A.
All right.
And then there's no other ways to write it.
Okay. Very good.
So, well, what I did this morning is I said that there's 4 cases. B goes first in one of them, so it's 1/4.
Uh-huh.
But that was not correct.
That's right. That is not correct. So I'm actually really glad you did it like this because that provides a great opportunity for us to look and see what is wrong with this scenario here. Because what's wrong with this scenario is a great illustration of some ideas in probability and counting. Do you have any ideas what's wrong with this approach?
Well, some cases might be more likely to happen than others.
Aha. So you're right, there are 4 cases, but the problem is that they're not all equally likely.
Well, these 3 here are all 1/32
Okay.
of the time. But this one, I guess, is 1/16. Because there's only 4 spots instead of 5.
Okay.
So, then that's, I guess there's just 5 out of 32 total.
Uh-huh.
And then this is 1 out of 32, so 1 out of 32 out of 5 out of 32, so 1 out of 5.
Very good. Very nice. Do you see a different way to list out the cases where they're all equally likely?
Well, you could maybe put like B. You could put A, B, A, B, and A, B, A.
There you go, because now you've got all of them have
1/32.
all of them have 5 slots now. So, and because all the things are independent, and it doesn't seem like you need to do this here, because once A won 3 games, it was over.
Mm-hmm.
But there's 2 other separate cases that they could be.
Right, it's just listing it out like this shows why this case essentially counts double. Right, there's 2 different, if you want to compare this case to this case, there's actually 2 of them. So that is why the answer is indeed 1/5.
Yeah.
Okay, so that's a really important lesson. You do want to count the number of cases that there are and divide by, what works and what doesn't work. But you do have to make sure all the cases are equally likely. All right, so let's take a look at the second problem now.